Okay, so this is lesson 5.4. So for long-term saving strategies, in this lesson, we're going to be looking at the effect of time on future value. So the whole thing of here, there's an old saying, the best way to start saving for the future was the day you were born, and the second best day is today. So here we're going to look at this situation. We have on the day their daughter was born, Bill and Samina invested $1,000 for her education. Ravit is now 18 years old. The interest earned was compounded monthly, and the investment averaged 7% interest per year. So A is asking to circle the 4 key pieces of information. So for starters, we have that they started with $1,000. It's been 18 years, so that's very important. And that it was compounded monthly, so every single month you got interest on it, and it was 7% interest per year. Okay, so here, if we then go to B, it says use the TVM solver, and I have the TVM solver on the right over here to solve this situation. I will write down the information that we took out, however, into this little box first. So we have here 18 years, and then we have a 7% interest, and then they started with $1,000. There's no payments with this, and we're looking for future value. They get paid every single year, so one time a year, and then it is compounded monthly, so 12 months in a year. So if you plug all that into your calculator, so we have 18, 7, minus 1,000, and then we have 12 right here. And then we're going to solve for FV, which gives us $3,512.54 after you've calculated it. So now we're asking how much interest was earned. So you have $3,512.54 is what you've made. At the end of it is what you have, but you put $1,000 in. So the interest that was earned on it was $2,512.54. And then how much interest would have been earned in saving account that paid. And now here it doesn't say it because it disappeared, but it's supposed to be 0.5%. So if we change that, so now we're asking per year, it's making 0.5%. So that means that our 7% that we had now becomes 0.5. Oopsies, wrong button, 0.5. And then we will solve once again for the future value. So your future value is 194.15. You'd put $1,000 in. So you're left with $94.15 as the interest earned. So now this one here you can explain yourself. Do your answers to part C and D confirm your thoughts about the effect on interest rates? Okay, and so for F, the next one you have, Ravi gets a job after high school and decides to let the money continue to grow. Assume that the investment continues to average 7% annually. By her 30th birthday, the original 1,000 will have become what? So if we go back here and we turn this back to 7, at her 30th birthday, so now there's 30 years, not 18, what will her future value be? Her future value will be 8,116.5. And then the investment will be how many more times than the original. So it's 8 times, but we'll show you how to calculate that. Is 8,116 divided by the original 1,000 you have gives you 8.11. So really it's roughly 8 times. Now in order to do the next part of 5.4, we need to do this tech tip first. because this is with regular deposits. So our TVM solver is going to change a tiny bit. So here, this has to do with question 2, which is in your worksheet. But here you start with nothing and then build the future by making regular deposits. Using the language of the TVM solver, your present value is going to be 0. So PV is going to be 0. And the amount of the regular deposit is the payment. And then PY is the number of payments that you'll make in a year. So how many times are you depositing money into your account? And N is the number of payments that are being made in total. So in this situation, if he is, one second, we'll go back up. So he is investing per week, $500 per week. Then how many times is he putting money in a year? There's 52 weeks times 2 years will give you 104. Okay, so the 104 times he's going to put money in. The interest in this situation is 6%. And then the amount of each deposit is the $50. So you can see there's already a minus right here. So they have it there for you. Future value is what we're going to calculate, so you leave it at 0. And then PY is the number of times in a year that you'll make a deposit. So there's 52 weeks, as we said. So there's 52 deposits. And then how many times is it compounded? In this one, it says compounded monthly. So you will do 12. Now you can come and put all these things into your TVM solver. So 104, 6%, 0, whoops. And then you're doing negative 50. Your future value is blank at the moment. And then this is 52. And we have 12. So we are going to be solving for future value. So you click solve for future value. And you can see that it is $5,520.84. So after 2 years, he would have $5,520.84 in his account. So now that we've done the tech tip, we can go back and then complete this table. So it has the same information. It was copy pasted. So $50 a week, 6% interest, compounded monthly. So here you'll have Gavin's age. So he starts at 15. So after 5 years, how old is he? So first off, we're going to fill out this entire part of the table. So every 5 years, how old will he be? All right, so he's going to be 65 at the end. Now, here we want the number of deposits. So you have 52 weeks times the number of years total. Okay, so the first one is going to be 5 years. So you have 52 times 5, which is 260. And then the next one is going to be 52 times 10, which is 520. 52 times 15, 780, and so on. So 52 times the number that you have on the left. Okay, so that's the number of deposits he makes. Now, we want to look at his future value. So here, one second, we have the number of payments is what's really going to be changing. So you have the first one is 5 years. We already have the $50 per pay It's every week, so 52 weeks for PY, and CY is compounded monthly. So here we can just put in our 260, and then we solve for FV, and it gives us $15,145.80. And then you do that for every single one. So you're going to come here and you are going to change this number to 520, solve for FV, and it is 35,575.40. Okay, so you'll do that for every single one. And I already have them calculated, so I will just plug these in, but you should be able to simply change that first value. All right, so this is what we get at the end of it. Now, here, if he is 65 and he had been investing $60 a week, how much would he make at that point? So in this case, you're going to be changing your PMT, your payment, to minus 60. So you're going to have over here, instead of 50, you are at minus 60. And we are doing, oops, I forgot a 0 here. So we are doing the last one, so 2,600, solve for FV, and you have, this is how much you would make. It's $986,561. So that's how much he would make had he been putting $60 away. And then here, this one here is to determine how much he would make if he was averaging 8% with the $50 a week instead of 6%. So we're going to change our investment here to 8, go back to 50, and solve for FV. Once again, if it wants to do it, there we go. Nope, I feel like that's not right. It did not change. There we go. So 1,722,941. And that is the end of 5.4.